All right, welcome to Next Gen Manufacturing. Today, we're going to dive into a component that is absolutely essential to modern industry, but, it often flies completely under the radar. It's small, it's incredibly precise, and honestly, without it, the high-tech world we live in would it would fall apart. We are talking about the tool holder.
Think about it for a second. In manufacturing, precision isn't just a nice-to-have, it's a flat-out requirement. We're talking about anything from a jet engine turbine to a surgical implant. The difference between success and total failure can be measured in microns. So the big question is, how do you guarantee that level of perfection, not just once, but millions of times over? Well, the answer starts right here.
Okay, let's get into it. This is the unsung hero of the whole operation, the tool holder system. You can basically think of it as the ultimate translator, the one essential link that takes a perfect digital design from a computer and turns it into a perfect physical object.
Now, on the surface, its job sounds pretty simple, right? Just hold a cutting tool, like a drill or an end mill. But it is so much more than that. The tool holder is that critical interface, the connection that ensures every single rotation, every movement, and all the raw power from the machine is transferred to that cutting tool without the slightest error. It's the bridge between instruction and action.
So, you might be wondering, how does this one little component pull off such a monumental task? Well, to really understand its genius, we kind of have to pop the hood and see how it works. Let's break down the anatomy of a tool holder. At its core, it's a system of just a few key parts, but they have to work together in perfect harmony. You've got the shank, which is what connects to the machine, and then you have the other crucial components that grip the tool and lock it all down. So let's break down each one. First up is the shank. Think of this as the foundation of the whole setup. It slides directly into the machine's spindle, and its entire job is to transmit all of that power and rotational force. The connection here, it has to be completely flawless.
Next, we have the collet, or the chuck. This is essentially the hand of the operation. Its one and only job is to grasp that cutting tool with incredible force and precision, making sure there is absolutely zero slip no matter the speed or what material it's cutting.
And finally, you have the flange and the taper. This is what guarantees that perfect, stable alignment between the tool holder and the machine itself. A secure, rigid connection right here is everything. Everything, because it minimizes vibration. And vibration is the arch nemesis of precision machining.
And speaking of enemies, that brings us to the main villain of our story, runout. Runout is just a term for any tiny off-center wobble in the rotating tool. Even a microscopic wobble can lead to a terrible surface finish, wear out your tools like crazy, and just completely destroy the dimensional accuracy of a part. It is the one thing every machinist is constantly fighting to eliminate.
So, how do we fight that wobble? Well, a perfect tool holder system is your first and best line of defense. But here's the thing about modern manufacturing. It demands not just precision, but also speed. And that's where the technology has taken a huge leap forward, tackling both of those problems at once. And that leads us to one of the biggest leaps forward in tool holder technology ever, the quick change revolution. This is really where next-gen manufacturing kicks into high gear. And wow, this just shows you the difference perfectly. The old way meant these long, manual tool changes where you could lose accuracy with every single swap, and the downtime was just a killer. The next-gen approach, we're talking rapid-fire tool swapping with repeatable, perfect positioning every single time. This slashes changeover from minutes to mere seconds. It maximizes productivity and gives operators way more flexibility. It's a complete game changer.
Okay, so we get the components, we get the technology, but how do you make sure you're getting absolute peak performance from your tool holder system out there in the real world? Let's get practical.
First off, proper installation is just non-negotiable. It all starts with making sure both the holder and the spindle are perfectly clean. Even a tiny little chip can throw everything off. Then it's a simple process. Insert it, secure it properly with the machine's mechanism, and then, this is key, always verify that it's seated securely before you hit that start button.
Beyond that, there are kind of 4 golden rules. First, compatibility. Make sure your holder, your machine, and your material all get along. Second, use the right clamping force. Too much or too little can cause huge problems. Third, maximize rigidity. Choose systems that dampen vibration. And here's a pro tip, always use the shortest tool possible for the job. And finally, just basic maintenance. Keep your gear clean and it'll keep you precise.
So, we've gone deep into the mechanics, the tech, and the best practices. But let's zoom out for a second. Why does this microscopic level of precision, all dictated by this one single component, truly matter in the grand scheme of things?
Because the journey to every single flawless product that we rely on, it starts right here. That unbelievable precision that allows for life-saving medical devices, the complex components inside our phones, or the critical parts that make electric vehicles go, it all begins with a tool holder enabling one perfect cut repeated flawlessly over and over again.
And this really says it all. A robust tool holder system isn't just about making one good part. It's about enhancing productivity, saving you money by reducing tool wear, and consistently producing workpieces of superior quality. It's the very foundation of efficient, modern manufacturing.
So I'll leave you with this thought. As we race towards a future that's going to be dominated by AI and robotics, it's really easy to overlook the physical engineering that makes it all possible. The tool holder reminds us that sometimes the real key to unlocking the next generation of technology isn't just in the code, but in perfecting the simple tools that connect our digital world to the physical one. Makes you wonder, what's the next one going to be?